Welcome to our lesson on ratios and proportions. So, to begin with, what is a ratio? Well, a ratio is nothing more than a comparison of two quantities. Okay? And this can be written as, say, in this notation, it can be written in fraction notation, which is what we are going to use most of the time, or it can be written in word notation 3 to 1. So, something to keep in mind, order matters. Okay? So, let's say that the quantities that we are comparing are, say, like the number of let's see, the number of gears, or actually no, the number of let me change this here. So let's say it is the number of teeth in gear one. And we are comparing that to the number of teeth in gear two. Okay. So if we are creating a fractional ratio where we have the number of teeth in gear one, and we are comparing that to the number of teeth in gear two, then when we move forward and start talking about proportions where we are comparing two ratios, uh, it matters that you have to leave the item that's in the numerator of the fraction has to remain there, and the item that's in the denominator of the fraction has to stay there. And like I said, we'll take a look at this in a little bit more detail as we get into proportion. But for now, just keep that in mind. Okay. All right. So let's start talking about, in particular, let's look at some gear ratios since we're talking about gears. Okay. So we have a gear ratio. This is one of our common ratios that we're going to see in this course. And this means that the driven gear, or in other words, the output, is being compared to the driving gear, or the input. So, for example, so let's look at an example. So we have an automotive technician who counts the number of teeth on a differential. The driving gear, so the driving gear has 10 teeth. And the driven gear, and yes, I am writing these like this just for notes, has 41 teeth. So, what that means is that our gear ratio, okay, so now we're going to turn this into our gear ratio. So we have our driven gear, which has 41 teeth, and our driving gear, which has 10 teeth. And what this means is that the gear ratio ends up being 4.1 to 1. So, what this means is that our drive shaft has to spin 4.1 times to rotate the tires exactly once. So, this is just one example of using ratios. So, let's look at some different types of ratios. So, we could also consider pulley systems. So, we have a pulley ratio. And in this pulley ratio, we would have the diameter of the driven pulley. Oh, did not spell that correctly. And that is going to be compared to the diameter of the driving pulley. So in this example, maybe we have an HVAC tech working on a blower fan unit. And we know that the electric motor has a 3-inch pulley. And the two little quotation looking things is an abbreviation for inches. We will see that repeatedly. And let's say that our fan shaft has a 9-inch pulley. So in this HVAC example, our pulley ratio is going to be 9 inches to 3 inches, or 3 inches to 1 inch when we reduce this ratio. And what this is telling us is that our fan spins 3 times slower than the motor. And for those of you who are not in automotive or HVAC, some of this is going to be a little bit foreign to you, but if you notice, we're still going to use the same process for all of these. Okay, so let's look at another example here, and this is going to come from construction. So we can talk about the roof pitch. Okay. And the roof pitch is how much does the roof rise compared to how long is the run. So our rise is what we call vertical change. or we could consider this up and down, because that's what vertical is. And run is the horizontal change. Or we could say side to side, or maybe left to right. But when we think about that, that's what we can kind of consider here. Um, and this is also something that, honestly, a lot of us are going to uh, experience in our life. Maybe we're purchasing a house or having our house remodeled or uh, something along those lines. So when we're thinking about roof pitch, let me draw us out a little picture here. So we have say like the roof on our house here. And we're going to make our roof look like this. And you all will learn very quickly that I am not the best artist, but what I do does get the job done. Okay. So when we think about this, okay, we need to think about this is how much the roof rises, and this is the run. So if we consider that if we consider that, say, this rise in this particular roof, okay, let's say that this is 4 feet. And let's say that the horizontal span is 12 feet. Okay. So we are going to convert this to a ratio. So the rise over the run. And we are going to use the tools that we have in our toolbox to reduce this ratio, which it's just reducing a fraction. And we reduce this to 1/3. And what this means, okay, the meaning of this is that the roof rises 1 foot for each 3 foot horizontal span. All right. So now let's look at, change that over. Now let's look at solving proportions. So when we solve proportions, we are going to use what is called the cross product rule. Okay. And what that means is that if we have some value A and it's being compared to some value B, and we say that that is the same as some value C compared to some value D, then this means that A times D is equal to B times C. So if you notice, we kind of cross multiplied. Okay. And because those two proportions were already equal, we can say that their product is equal. The cross product is equal. So a great example of this, honestly, I think this is something that, to be honest, a lot of us probably use in even in our daily lives. So let's say that we have some recipe, and this recipe says that we need 3 cups of something. It doesn't matter what that thing is. Okay. 3 cups. And this is for a serving that serves 2 people. So remember in the very beginning, I told you order matters. And what that means is, what if we need to feed, uh, let's say we need to feed 16 people. So how many cups? And again, it doesn't matter what this product is that we're doing. Um, but a lot of us have done this even when we're cooking for the holidays that we celebrate, or family events or gatherings. Um, where we have this recipe that's been handed down to us, and it serves 20 people, but we only want to serve 3. So we can use these proportions to convert that recipe. So in this case, like I said, order matters. Okay. So because we have 3 cups being, we're told that it serves two people, order matters. The people have to be on the bottom. And let's just use X for our unknown here. Okay. So what we're going to do, we're going to cross multiply. And we're going to say 2x is equal to 48. So if you notice, all I did, I multiplied the 2 times the x and the 3 times the 16. Then if I divide both sides by 2, we get that x is equal to 24. So this means that in order to scale our recipe so that it would serve 16 people, we would need 24 cups of whatever this ingredient is. Okay? So let's take a look at um, a couple of quick examples here, and then we will wrap up this lesson on ratio and proportion. Okay. So the first one that I want to look at, let's say that we are given this equation. So 2 over 15 is equal to 8 over h. Well, here we are going to use our cross product rule to cross multiply. Okay. And we are going to end up with 2 times h is equal to 8 times 15. I'll work this one out a little bit more in detail for everybody. So this tells us that 2h is equal to 120. Okay. And then we're going to divide both sides by 2. And we're going to say that H is equal to 60. So let's take a look at another example. So we're told that for some printing job, we know that the paper weighs 12 pounds per 5,000 sheets. So, what is the weight of a print job that needs 12,500 sheets? Well, again, order matters. Okay? When we are looking for weight, that matches with our 12, the pounds. So we can say that we have 12 over 5,000 equal to X over 12,500. Okay? Um, and for this one, because this one is not it's not nice numbers that we can just decide in our head what they are. And I'm not going to work this one out in a lot of detail like I did with the previous one. So this is going to tell us that 5,000 X is equal to 150,000. And when we divide both sides by 5,000, we discover that the weight of this print project would be 30 pounds. Okay, so I hope this helps with understanding ratio and proportion. If you have any questions, please do not hesitate to reach out.